Alright, let's go. The learning goal: use the periodic table to identify elements and compounds. If you are at a level 3, you are able to use the table to determine the atomic number, the atomic mass, the protons, the neutrons, the electrons, and the number and types of elements in a compound. If you are at level 4, you are able to do everything in level 3, and you're able to use the periodic table to explain why an element is in a certain period and group of the periodic table, basically explaining how it's organized and why things are the way they are. Let's go. So the periodic table of elements is an organized table showing all of the known atoms that make everything all matter we know of. Some of the elements are man-made, mostly on the bottom, the radioactive ones, and most of the elements occur naturally. So we know from 7th grade, we know that all of this matter really comes from an exploding star. All matter is made of that exploding star, and even we are made of that. So that's where we think this matter comes from. It's the best theory so far, known as the Big Bang. And the periodic table, basically, we need to know what can we learn from it. So the periodic table has all the elements, but it just has a symbol. The symbol is the first one or two letters, or sometimes the symbol is taken from the Greek or the Latin, such as like lead. It doesn't really have the first two letters. So sometimes the name is taken from the person who discovered it, such as Einsteinium, or it can also be named after where it was found. Okay? So if you know some basic information about the periodic table, you may know that the first number, or the smallest number you'll see on one of the elements, is the atomic number. And this atomic number is also the number of protons in that element. So these atoms are made of protons, neutrons, and electrons. And so the atomic number represents the number of protons in that element. And then the letter is the atomic symbol. Scientists like shorthand. We use symbols to represent things like units of measurement, also elements. And then down the bottom we have atomic mass. So some basic things we need to know. The atomic mass minus the atomic number equals the number of neutrons. So approximately how many neutrons would be in this element boron? Okay, well, hopefully you said 5. Okay, one way I remember this is by just using an acronym MAN. M meaning atomic mass, A atomic number, N neutrons. Another one. Atomic number equals the number of protons, and it also equals the number of electrons. So if the atomic number is 5, the number of protons is 5, and the number of electrons is, hopefully you said 5. Okay? So that is hopefully information that is reviewed to you. If it is not, great time to relearn it. Let's keep going. Alright, some brand new information. Electron levels. Okay, so we know up here that this is the atomic number, and the atomic number is equal to the number of protons and the number of electrons. Electrons are these extremely small particles that are buzzing around the protons and neutrons. Okay, so as they are buzzing around, there are levels, and these levels have a certain number of electrons that can go into them. Up here you will see that number. So on this particular periodic table, it had how many electrons were in each level. So there were 2 in the first level. Okay, so that level was full. There were 3 in the second level, and it can hold up to 8 in that second level. So that second level is not full, but that's it. So the total number of electrons is equal to, you could say the atomic number, you could say number of protons. Okay, so here's what boron might look like. So that's electron levels. Moving on. Alright, so crazy stuff. Where did it all come from? A little bit of history. Periodic table is set up with a trend in mind. If you think of examples of a pattern or a trend, you know, I think of what students wear to school. Okay, different trends become popular at different times. What was a trend last year may not be a trend this year, but a trend is a pattern, something we see over and over and over. So Dmitri was kind of one of the main guys who we credit with putting a lot of these elements in order. And he put the elements in order by atomic mass and put things with similar properties together. So when Dmitri was around, there were all these elements, and they really needed to be organized in a fashion that was readable. And so Dmitri kind of put that together with atomic mass and similar properties. Then Moseley came along and said, well, you know, atomic mass may not be the best way because it can change depending on the number of neutrons, and so he put it in order by atomic number, or number of protons. Okay, so Moseley kind of built on the information of Dmitri, made it a little more clear, readable, understandable for scientists to use. So families and groups. Families and groups are kind of the same thing. Sometimes you'll hear them referred to as families. Sometimes you'll hear them referred to as groups. And then periods. Okay, so periods are the rows. Groups and families are the columns. In periods, all elements in a period have the same number of electrons in their last level. Okay, that's important. So, for example, so periods have the same number of electron levels. For example, you know, look at period 2. Okay, in period 2, you'll see, if you go across period 2, you'll see that all of those elements have 2 electron levels, because there can be 2 electrons in the first level and up to 8 in that second level. Okay, so if you look across, you'll see that, you know, lithium will have 2 levels. And if you go all the way across to neon, neon will also have 2 levels. Okay, so we have all elements in a period have the same number of electron levels. Groups or families have similar properties, and you'll see kind of a key to the groups or families down at the bottom. Okay, so if we look at these noble gases, they're saying that these are inert elements. Okay, and we can learn more what that means later. If you see these, this light blue color, it says alkali earth metals. Okay, so all metals we can find in their natural state, solid on Earth. Alright, so that is that. some information about groups or families. Metals are metals at room temperature. Exception to that is mercury. It's a liquid metal. They reflect light, they can be shaped, they conduct heat and electricity. These descriptors are what we mean by properties. And then nonmetals have their own properties, metalloids have their own properties. So groups or families are those columns, and they are grouped by similar properties of elements. Alright, so that's it, that's all. Kind of reviewing our learning goal. Hopefully out of this you will know, you'll be able to use the periodic table and understand the atomic number, atomic mass, number of protons, neutrons, electrons, number and types of elements in a compound. Okay. We will go over a little bit more compounds and how they can be read and understood in class. But hopefully you have almost, if not all the way at level 3. Going above and beyond level 3, you are understanding why groups and families are the way they are, and why elements are organized the way they are in the periodic table. Alright, if you have any questions, you can always email or ask me in class. And later.